Okay, let's give you guys some more practice. So use trigonometric substitution to integrate this. So press pause and have a go. Okay, so to do this, your eyes should zoom into this complicated bit here, and then create your right angle triangle in such a way that this will be true. So if you make this to be x, and if you make this to be 3, then the opposite will have no choice but to be square root of x squared minus 9. So in order for you to integrate this, so hang on. So in order for you to integrate this, your eyes should zoom into this bit here, and then create a triangle, a right angle triangle in such a way that this here will be true. So if you make the hypotenuse to be x, the adjacent to be 3, then the opposite will have no choice but to be this. So once you've got your triangle, then you can jump to here, because if you look at the diagram, secant theta would be this. Secant theta would be x over 3. So secant theta would be x over 3. Secant theta would be x over 3. So once you've got your diagram, jump to here. Once you are here, then times both sides by 3. So that would take you to here. Once you are here, then differentiate both sides. So when you differentiate this, it will give you this. Then you've got your d theta. Differentiate this, then you've got 1, but then it will be dx. So dx equals this thing here. So now we can put this into the dx, and then go back to your diagram, which is here, and then if you look at this, tan theta will be opposite over adjacent. It will be opposite over adjacent, times both sides by 3. So this complicated bit here is 3 tan theta. So we can put 3 tan theta into this complicated bit here. And then now you've got to take care of x to the power 3. So go back to here. If at the moment x equals this thing here, so cube both sides. So if you cube both sides, then that will give you this, and this will be 27 secant to the power 3 theta. So now we can put this into here. So this whole thing here will then become this. This whole thing here will then become this. So now tidy this up. So 3, 3. This will then become a 3, and then you've got your tan theta, merge these two together. That will give you tan squared, and you've got 1 secant here, and you've got 3 secants here. So it will become a 2. So this whole thing here will then become this. Tidy it up. So factor out the third here. So take it out because it's a constant, and then now visualize as this. You've got tan squared, but you got tan squared divided by secant squared. So visualize tan squared as this. This here is tan squared. This thing here is tan squared, and then so visualize tan squared as this, and then you've got your divide. So that's your divide here, and then visualize this the secant squared as 1 over cos squared. So now you've got one fraction divided by another. So when you divide, you times the reciprocal. So cos squared over 1, and then top and then these two will cancel each other out, giving you sine squared theta. So now we are at this stage here. So remember, to integrate sine squared theta or cos squared theta, we normally use this. We normally use this here. In the case of cos squared, well, you should already know this. So in order rewrite this as this. So rewrite as this. So rewrite this as this. Okay. So this whole thing here is this thing here. So now tidy it up. This whole thing here will then become this. So now this is straightforward to integrate. So when you integrate it, it will give you this. So tidy it up. It will then give you this. Now this is our answer, but we don't want the answer in terms of theta. So we need to translate theta back into x. So now so we need a way of translating this theta and this theta, but this theta here is locked in with this 2, and so this 2 theta here is locked in with this sine. So we need a way of breaking this up. So so we would then use this. So this thing here, we rewrite it as this. So now well, this thing here is this thing here. Okay, so now if you look at this, you see this theta here is locked in with the 2 is locked in with the sine. So here you've got one block, but by using this, we now have one block times another block here. So we need a way of finding out theta and sine theta and cos theta. Up here we couldn't do it, so we had to use this. So now we are currently here. Now that we're here, tidy up. So this thing here will then give you a 6 here, and then now revert back to your diagram. So currently we are here. Now go back to your diagram. We need a way of translating this sine theta and this cos theta. So by looking at the original diagram from above, sine theta would be this. This is sine. So sine theta would be opposite over hypotenuse over hypotenuse. We need a way of translating cos theta. Look at the diagram. Cos theta would be this. Cos theta would be this. Would be 3 over x. Would be 3 over x. So now we have a way of translating this. Cos theta here would be this. So now this theta here, you can either use this or you can use this. Select the simplest one. Let's select this. So theta is really inverse cos of 3 over x. So now we can put this. Hang on. We can now put this into here. Put this into here. And for the theta part, let's use this. So theta. So looking at this here, theta would be inverse cos of 3 over x. So we can put this into here. Okay, so this whole thing here would then become this. And then tidy up, and then your overall answer would be this. Okay.